Well, hi guys. We're going to go ahead and jump into lesson 1.3 in phase changes, investigating the molecular scale. So the first thing we're going to do is we're going to jump into our warm-up, and I'm going to bring up Amplify. So we're going to answer the following questions about Titan and its disappearing methane lakes. And you can refer to the Titan fact sheet right here that's from the last lesson. It's linked here if you need it. Number one, write a question you have about Titan or about methane that can help you understand and determine what happened to the lake. Number two, liquid methane and water are different, but they have some things in common. What are some things that all liquids have in common? Pause here and answer these two questions. And as you go through the lesson, just pause so you can do each individual part. So we're going to go on to activity two, considering molecules and phase changes. So in the previous lesson, we actually discussed the appearance of substances at a macro scale, so big scale, during everyday phase changes. Those key concepts summarize what you were able to observe as a human with just your eyes. So knowing knowledge or having knowledge about the differences between the phase is not enough to help us solve the mystery of this lake on Titan. We can't travel to Titan to see how the methane works there or if it's invisible, so we have to do it in other ways. First, we need to understand more about what makes the phase different and what happens during freezing and evaporation. We can't always tell with the human eye. We may need a little bit more to help us to be able to see. So we will observe at two different scales. We have our macro scale, and the macro scale is substances that can be observed with the human eye, like liquid water. The molecular scale is molecules that are too small to be seen with the human eye, such as a water molecule. We can't see those on an individual level. So we are going to focus on the word scale. Now, this actually goes back to one of your cross-cutting concepts, if you remember. Which one is it? That's right, scale, proportion, and quantity. So scale is the relative size of things. And then we're going to look at the other vocabulary, which is molecules. And molecules are just a group of atoms that are joined together in a particular way. And we're going to gain more experience with phase changes by observing substances in different phases at both the macro scale and the molecular scale. Okay, so think about that. Macro is big, we can see it with our eye. Molecular scale is small, we need something to help us to be able to see it. And you guys will have these materials on the side of the classroom by the teacher desk. They'll be either laid out there for you or they'll be in the drawers of the colored drawers that are labeled 1 through 10. You can borrow those for your group or lab tables. So a couple of safety guidelines. Guys, when you guys are doing labs, please, please, please make sure you're following all the safety guidelines. So follow instructions, don't taste things, smell substances like a chemist, which is wafting, where you swish the air over to your nose, not sniffing it directly. Protect your eyes if needed. Safety glasses are in the classroom if you need those. Protect your hands. Keep your hands away from your face. You don't want to get anything in your eyes or your mouth. Tell your teacher if you have allergies. Be calm and careful. Report all spills and accidents to your teacher and avoid anything that could cause a burn, and make sure you wash your hands after class if you touched any materials. So I have a hot water dispenser, and you can fill the foam cup up with hot water and then place the plastic cup on top so you can observe any changes that occur. Now there are some magnifying glasses, so you're welcome to use those to see if you can see it at a smaller scale. It actually does help, so you should try that out. So what changes in phase did you observe? What is your evidence? Now make sure if you observe it, you need to tell me what your evidence is. So one example could be evaporation. We saw liquid going to gas. Okay, what is your evidence? Look at the cup and determine what your evidence is. What evidence did you see in the form of gas? Okay, so you may actually see a gas in there, and you should be able to describe what is going on with that gas. What do you think caused the water to change from a liquid to a gas and then back to a liquid? Remember, these questions you should be discussing with your group so you can get a better understanding and see what their answers are. What do you think you would need to happen in order for the water to freeze and become a solid? All right, so back to the question. This question is going to help us investigate whether the lake on Titan evaporated or froze. What happens to the molecules of a substance when it changes phase? So you've thought a lot about the macro scale appearance of phases from previous lessons. Now let's focus on that micro scale. So you're now going to have a chance to think about what happens to the substances at a molecular scale and draw a model that shows your predictions. So if you look in the packet of papers that I gave you, at the beginning of this unit, you will find this paper here if you'll look for this one. And you're going to be drawing your model on that paper. So you're going to make that model showing what you think might happen to water molecules at the molecular scale of each phase. Be sure that you hop back into Amplify, and there are 2 cards on this part of the lesson. Remember, this is Activity 2. There are 2 cards for you to look at and answer a few questions, so make sure that you do that before moving on from this section. Okay, you can pause it here to make sure you complete Activity 2. I'm going to move on to Activity 3. Introducing the simulation. So in this part, you're going to be using a simulation, and I'm going to hop back to Amplify to read this letter to you. So here's a letter we got as student chemists, since that is our role, from the doctor, Dr. Flores, the lead chemist at the Space Agency or the Universal Space Agency. So this is about the phase change simulation you're going to do. You're off to a great start with your investigation of phase changes. Today you'll explore the phase change simulation to further investigate Titan's methane lake mystery at the molecular scale. As you read in this lesson, read in this last lesson, Titan and Earth are similar in a few important ways. As molecules behave the same way everywhere in the universe, this simulation will help you understand the phase changes that occur on Titan. I look forward to your next update. So if you scroll down below, there is a phase change simulation. You're going to want to go ahead and click on this. And as you explore, you're going to look at what you can do or change in the sim and what you think you can learn from the sim. When you open up the sim, this is what it should look like, and you should just explore and see what this sim can do. Okay, now that you've explored the sim, choose 1 or 2 of these pair share questions to discuss with your group about the sim. What was interesting to you about the sim? What could you do or change in the sim? What important features of the sim, or what seem to be important features of the sim, or what do you think you can learn from the sim? Make sure you discuss these with your partners because they may have noticed a few things that you may not have, and you may have noticed some things that they didn't. So a few things you may or may not have noticed is that you can turn on and off the kinetic energy and how fast these particles move. There's also a temperature scale over here. You can cause them to rotate, bump, or rotate in a different direction. You can change the different substances. You can even turn off gravity or put energy into it or take energy out of it. Those are just a few things. You can even speed it up over here and hit play to start. There's also a time section for you to be able to figure out how long your sim has been running. So remember the spheres that you see represent molecules. And those molecules, you can hit play and observe their motion. And on the right, as we said, there are 4 different substances. Each has different attraction levels. So you can change those substances and see how they are differently attracted. You can transfer that energy in by pressing the plus or minus. We already discussed that. You can actually press on one molecule to track it, and you can click on 2 molecules at one time to track their motion and where they're going in the sim as well. So here's our next question for you. What are some ways that this model is different from real molecules of a substance? Well, if you said that they are different because these are much larger. They're shown in different colors. Those are great answers. What other answers can you come up with? So before we investigate more, let's identify each of the substance. Based on what you observe as we tilt, what is substance A? Substance A is probably a solid, you're right, because its shape doesn't fill the container when we rotate the container like you see in this slide. How about substance B and C? What do you think those are? You don't need to identify substance D right now, but what do you think that B is? B is probably a liquid. You're right. It fills the bottom of the container and seems to flow rather than move in one or as one piece. Then C, we'd probably say is a gas because it actually fills the container rather than falling from the bottom of it or falling to the bottom of it. All right, in activity 4, if you need to pause it to finish up activity 3, I'm going to move on to activity 4. So we're going to look at Amplify. I'm going to flip back. You should have recorded those that data that we just discussed in this table. And if you'll skip over to card 2 asks you to look at your mission. If you haven't already done so, open that sim that you launched in the previous part. You should already have it open. And you're going to cause the substance to change phase and observe what happens to the molecules when it does change phase. Remember, you're going to want to track 1 or 2 of them and press on them so you can observe them. Recall the hands-on investigation that you did earlier and the observations that you recorded in the data table in part, I think that was 2, and discuss which of these would be the best supported claim. So read these claims below again. These are the ones that we got from the forum. Which one do you support right now? Pause the video and answer this question. You can discuss it with your group members if you need to. So use the sim to help you get evidence to back up that claim by adding energy or taking away energy to see what happens to the molecules. You can select a couple to track them, think back to that activity that we did, and come up with your answer on which one you think is correct at this moment. Okay, now onto your should do for 1.3. If you get this far and you're working on this, I'll show you how to do it. So you're going to consider what you would change or add to your model based on what you've learned about molecules and phase changes so far. Remember that you will also need to take your modeling molecules and phases sheet home to do this. You should have this if you're in class already, the pictures that you drew earlier in the lesson. So on your homework, if you go into the homework, there are a couple of questions. So make sure you do what you the questions based on what you've seen in this sim. So for part 5, there is actually only one question. What could you change or add? The one that we just mentioned. So make sure you answer that question here.